Welcome to TechTide Digital Lifestyle, your channel for practical electrical and technical learning. In today's tutorial, we are going to understand one of the most important motor starting methods used in industry, which is the star-delta starter. In the previous videos of this playlist, we already learned about electrical drawing basics in the Dole starter, including its power circuit, control circuit, and working principle. Before start this lecture, please subscribe TechTide Digital Lifestyle and like this video. But when we deal with large three-phase motors, starting them directly using a Dole starter can create a serious problem. When a motor starts, it draws a very high starting current, sometimes 6 to 8 times its rated current. This sudden current surge can cause voltage drop in the power system, overheating in cables, and even damage to electrical equipment. To solve this issue, engineers use a different starting method called the star-delta starter, which reduces the starting current and allows the motor to start more smoothly. In this video, we will learn the complete concept of star-delta starting step by step. We will start by understanding why it is needed, then we will study the required components, the power circuit diagram, the control circuit diagram, and finally the working sequence of the system. This tutorial is part of our Electrical Drawing Basic to Advanced playlist, designed for students, technicians, and professionals who want to build strong electrical knowledge. So stay connected, watch the video carefully, and let's start learning the star-delta starter in a simple and practical way. DOLVS star-delta comparison. Before we move further, it is important to understand the difference between a DOL starter and a star-delta starter. A direct on-line starter, or DOL starter, is the simplest way to start a three-phase motor. In this method, the motor is connected directly to the full supply voltage when the start button is pressed. Because the motor receives full voltage immediately, it also draws a very high starting current. For small motors, this is usually not a problem. DOL starters are commonly used for motors with smaller power ratings where the electrical system can handle the starting current without causing voltage drop. However, when we start large motors, the situation becomes different. Large motors require more power, and if they start directly with full voltage, they can draw a huge current from the supply. This can affect other equipment connected to the same electrical system. This is where the star-delta starter becomes useful. The star-delta starter reduces the starting current by initially connecting the motor windings in a star configuration. In this configuration, each winding receives lower voltage, which reduces the current drawn by the motor. After the motor starts and reaches a certain speed, the connection automatically changes to delta configuration, where the motor receives full voltage and operates normally. Because of this two-stage starting process, the star-delta starter is widely used in medium and large industrial motors. Understanding this difference helps us see why star-delta starting is an important concept in electrical engineering. Star-delta concept. Now let us understand the basic concept behind star-delta starting. Three-phase induction motors usually have three stator windings. These windings can be connected in two different ways, star connection and delta connection. In a star connection, the ends of the three windings are connected together at a common point called the neutral point. The other ends are connected to the three-phase supply lines. Because of this arrangement, each winding receives only phase voltage, which is lower than the line voltage. As a result, the current flowing through the motor during starting is reduced significantly. This is the key advantage of starting the motor in the star configuration. However, if the motor continues to run in star connection, it will not produce its full power. That is why, after the motor starts and gains speed, the connection is changed to delta configuration. In the delta connection, the windings are connected end-to-end in a closed loop. In this configuration, each winding receives the full line voltage, allowing the motor to deliver its full rated power and torque. So the basic idea of the star-delta starter is very simple. First, start the motor in star connection to reduce current. Then switch to delta connection for normal operation. This switching is done automatically using contactors and a timer relay in the control circuit. Required components. Now let us look at the main components required for a star-delta starter system. The first and most important component is the main contactor. This contactor connects the power supply to the motor during operation. It acts as the main switching device in the circuit. The second component is the star contactor. This contactor is responsible for connecting the motor windings in the star configuration during the starting period. The third component is the delta contactor, which connects the motor windings in delta configuration after the starting period is complete. Another important device in this system is the timer relay. The timer controls the transition between star and delta connection. When the motor starts, the timer begins counting. After a preset time, it switches the connection from star to delta. We also use an overload relay, which protects the motor from excessive current or overheating. If the motor draws more current than its rated value, the overload relay will trip and disconnect the circuit. Additionally, the system includes start and stop push buttons. The start button is used to start the motor, while the stop button is used to stop it safely. Finally, the system includes the three-phase induction motor, which is the main load being controlled. All these components work together to create a reliable and efficient motor starting system. Star-delta power circuit. Now let us examine the power circuit of the star-delta starter. In the power circuit, the three-phase supply lines L1, L2, and L3 enter the system from the main electrical source. These lines pass through protective devices such as circuit breakers and overload relays to ensure safe operation. From there, the supply is connected to the main contactor, which acts as the primary switching device. After the main contactor, the circuit branches toward the star contactor and the delta contactor. These contactors control how the motor windings are connected during starting and running conditions. During the starting stage, the star contactor closes and connects the motor windings in a star configuration. This reduces the voltage applied to each winding and limits the starting current. Once the motor reaches a certain speed, the star contactor opens and the delta contactor closes. This reconnects the motor windings in delta configuration, allowing the motor to operate at full voltage. The power circuit therefore controls how electrical power flows from the supply to the motor windings, depending on the stage of operation. Understanding the power circuit is important because it shows how the motor receives electrical energy during different phases of starting and running. Star-delta control circuit. Next, let us understand the control circuit of the star-delta starter. The control circuit is responsible for controlling the operation of the contactors and ensuring the correct switching sequence between star and delta connections. When the start push button is pressed, the control circuit energizes the main contactor and the star contactor simultaneously. This connects the motor windings in star configuration, allowing the motor to start with reduced current. At the same time, the timer relay is activated. The timer begins counting according to a preset delay, which is usually a few seconds depending on the motor size and application. During this period, the motor accelerates and gains speed while running in star configuration. Once the timer reaches its preset value, it automatically changes its contact position. This causes the star contactor to open and the delta contactor to close. As a result, the motor windings are reconnected in delta configuration, allowing the motor to receive full voltage and operate normally. The control circuit also includes interlocking contacts to ensure that the star and delta contactors cannot operate at the same time. This is a very important safety feature. Now let us understand the complete working sequence of the star-delta starter step by step. First, the operator presses the start push button. This activates the control circuit and energizes the main contactor and star contactor. Because the star contactor is active, the motor windings are connected in star configuration. In this stage, the motor starts rotating while drawing reduced current from the supply. At the same time, the timer relay starts counting. After a few seconds, once the motor reaches a sufficient speed, the timer relay changes its contacts. This action causes the star contactor to open, disconnecting the star connection. Immediately after that, the delta contactor closes, reconnecting the motor windings in delta configuration. Now the motor receives the full supply voltage and continues running at its normal operating condition. This entire switching process happens automatically and ensures a smooth and efficient motor start with reduced electrical stress. Safety interlock. One very important safety feature in the star-delta starter is the interlock system. The star and delta contactors must never operate at the same time. If both contactors close simultaneously, it can create a direct short circuit between phases, which can cause severe damage to electrical equipment. To prevent this, the circuit uses electrical interlocking and sometimes mechanical interlocking. Electrical interlocking uses auxiliary contacts from the contactors to block the opposite contactor from operating. For example, when the star contactor is energized, its auxiliary contact prevents the delta contactor from activating. Similarly, when the delta contactor is active, it prevents the star contactor from closing. In some systems, mechanical interlocks are also used. These physically prevent two contactors from closing at the same time. These safety mechanisms ensure that the switching between star and delta happens in the correct sequence without causing electrical faults. Industrial application star-delta starters are widely used in many industrial and commercial applications. They are commonly used for starting pumps, compressors, conveyor systems, fans, and heavy machinery motors. These types of equipment often use medium or large motors that require controlled starting methods. By reducing the starting current, the star-delta starter helps protect electrical systems, prevents voltage drops, and increases the lifespan of motors and cables. In this video, we learned the basic concept of star-delta starting, the required components, the power circuit diagram, the control circuit, and the working sequence. Understanding these diagrams is very important for anyone who wants to learn electrical drawing and motor control systems. In the next video of this playlist, we will continue learning more advanced motor control circuits and practical electrical applications. If you found this tutorial helpful, please subscribe to TechTide Digital Lifestyle, like this video, and share it with others who want to learn electrical engineering step by step. Also, don't forget to watch our electrical drawing tutorial playlist and other technical tutorials available on this channel. Thank you for watching, and I will see you in the next lesson.